बिल्डिंग पर मार्बल जाना संडे सच में कितने का टिकट है 140 ना 180 वो पता था 190 छह लोग को 440 का पर पर्सन 440 पर पर्सन तीन ही सौ टोटल biotest and the preparation still care and we अगर स्टार्टिंग से और बड़े छोटे हो जाएंगे केमिस्ट्री से 3 घंटा लगेगा 3 घंटा
Where did we stop in the last class? We started with conservation of energy.
We had to start with conservation.
Okay, all the energy conversions were completed.
Yes.
So any doubts in energy conversion? There are so many of them. Okay. So question: during energy conversion, is 100% energy converted?
No.
No. So what is the wasted energy?
Heat energy.
Heat energy. And what is it? Degraded. We call it degraded. And how do we convert energy from one form to another? Through some device. Okay, so there is an equipment made to convert energy from one form to another. All right. So now we are going to learn about conservation of energy. Conservation of energy, which is part 3 of this chapter. Right. So let us understand what it means. It means that energy of the universe is constant. Okay, whatever energy of the universe is, it is that much. it cannot be created or destroyed, right? So energy it means energy cannot be created or destroyed. It can only be changed from one form to another. Okay, this is what it basically means. So we are actually going to prove this statement or verify this statement with the help of two examples. So verification of using. The first example is during rainfall relief of a body. Okay, during rainfall of a body. In these two processes, we will verify the conservation of energy and oscillation of simple pendulum. Okay, so let's prove or verify the conservation of energy using the first example, which is really falling body example. Really falling body. So let us understand. Let's say this is Earth. Imagine you have a ball which is at some height h initially. So it is at a height h above the ground. Right? When it is dropped, so let us say this is some position midway during its free fall. Right? And this is just when it hits the ground, just before hitting the ground. Okay, almost touching. Right? These are the three scenarios. What is the initial position? This is position A, this is position B, this is position C of the ball. This is the initial position. So at every position, we will find out its mechanical energy. Right? So what is its mechanical energy? It is the sum of potential energy and kinetic energy at that point. Right? So what is the potential energy here? Potential energy at position A is, let's say its mass is m, so it will be mgh. Right? Gravitational potential energy will be this much. So at top position, what will be its kinetic energy at A? 0. R m v a square. But V is 0, right? Equal to half m 0 square. This is 0. What is the total energy? Therefore, E is equal to total energy at A equal to potential energy plus kinetic energy. So what is it?
MGH.
mgh. 0, this is mgh. So total mechanical energy of the body at position A is mgh. So if the energy is conserved, then its energy at B also should be mgh, and at the ground also it should be mgh. This is what we want to verify. Now let us figure out what is the energy at B. So imagine it has fallen from here to here. It has fallen by distance x. Okay. So what is the position of B from ground? H minus x, right? What is the height of B from ground? H minus x, because it has dropped by distance x. So what will be potential energy at B?
0.
0. What is the height? Gravitational potential energy depends on the height, right? So it is mg h minus x at this point, isn't it? Because what was the height at A? H. So what is the height of the ball at B? H minus x. So it will be mg h minus. Okay. Now what about kinetic energy at B? Let us say the velocity over here is Vp. mvp square. But what should be Vp? So initial velocity here was 0. The final velocity here is Vb. So Vb square minus 0 square is equal to 2gx. Right? So we have but Vb square minus 0 square is equal to 2gx, isn't it? 2as, remember? V square minus u square is equal to 2as. Acceleration is acceleration due to gravity. Everywhere on the ball, what is the acceleration? G, right? So 2g acceleration. What is x? The displacement covered. Everybody got it? We are applying equation of motion, the third one. V square minus u square is equal to 2ax. So what is the acceleration during the free fall? Acceleration due to gravity. How much distance is covered in traveling from A to B? X. That is the distance or displacement. Okay. So when we substitute Vb square divided by 2gx, so you all have got the attendance sheet. So we'll substitute Vb square here. So this implies what is Kb m 2gx. So Kb is equal to, therefore Kb is equal to mgx. Okay. So Ub was mg h minus x, Kb is mgx. Therefore total energy at B is mgh minus x plus mgx. Right? Because it is Ub plus Kb. What is it? Open this. This is mgh minus mgx plus mgx. Therefore, what is total energy at B? mgh. Total energy at A was mgh. At B also it is mgh. At C, right? What is the energy at C? So what is UC? What is the height at C at this point? 0, right? So it will be mg 0. This is 0. What is kinetic energy at C? Half m, let us say its velocity is vc square. Okay. But what is vc square by this logic? Vc, so initial velocity, let's say from above, right? So it will be vc square minus 0 square is equal to 2g. Now full distance is h. So what you will get? You will get 2gh. Okay. So what you will write? This is equal to half m 2gh, because we did this in detail. So I'm writing it directly. You know how we got it. So what is vc square? Right. So I'm writing since vc square minus 0 square equal to 2gh. That's why we are getting this. So now what has happened? Therefore, Kc is equal to mgh. So what is total energy at C? Dc is equal to U at C plus K at C. Potential energy at C plus kinetic energy at C. So this is 0 plus mgh. This is again equal to mgh. Right? So at various positions, you are finding that the total mechanical energy of the falling body is same only. So what is happening? Here it only had potential energy, no kinetic energy. In between, it had both, because here velocity was 0, but here velocity has got some value. So here it has both potential and kinetic. So how much is kinetic mgx? So potential energy, part of it has got converted into mgx, and the same part has been reduced. What is potential energy? Mgh minus mgx. So whatever is reduced from the potential energy is appearing as kinetic. Got it? So energy is converting from one form to other. It is not destroyed. So potential here is less, but that same less factor is appearing as kinetic energy. Therefore, total remains same. Now, just before hitting the ground, the entire potential energy is 0. But now the same energy appears as kinetic energy. Okay? So this verifies your conservation of energy. Energy cannot be created or destroyed. It can only be changed from one form to other. Throughout, its mechanical energy is same. Okay? Now when it hits the ground, then what happens? Its potential energy is 0. Now its kinetic is also 0. What happened to the energy? When it hits the ground?
It got transmitted into the ground.
Huh?
Before energy got transmitted into the ground.
Into the ground. Yeah, so like what happens? You heard sound? The energy got converted into sound and ultimately into heat. Okay? So now the energy is degraded. So it is given back to atmosphere as heat. Okay? So my energy is also energy of the universe. We are all part of the universe, right? When I work on the duster, that becomes mgh. When I left it, it hit the ground. So we got the energy from the universe, we submitted it back. It's like that. Right? What is the source of energy in me? Calories. Yeah, which comes from food, which comes from sun. So source of every energy is sun only. Okay? And it is not different for you all. Right? So we are getting energy from sun. So when we are returning it back to atmosphere, so it's going back from where it came. Okay. You want to make a note of it? So if anybody has any doubt, please ask. So what will you write? Will you write? Since Ek energy, total energy at A is equal to total energy at B is equal to total energy at C, which is mgh. Hence, the energy conservation has been verified. And has been verified. Is it making sense to you all, or is it becoming too deep? Is it okay? Huh? Okay, fine. So hence the energy conservation has been verified. Right. At A, the energy is only potential. At B, some part of potential energy is converted into kinetic energy. At C, entire potential energy is converted into kinetic energy. So there is loss of potential energy, which is appearing as gain of kinetic energy. It's not really destroyed anywhere, it just changed form. Can I erase the left side? Is everybody through right? So we have to get your diagram right. Okay. Then all these equations are very easy. So our displacement is x actually. This diagram is x. Shall I? Okay. Let us plot the potential energy graph, right? So we'll start with the beginning. When x, so x is varying. X is, what is the value of x at the top? Like, okay, we should call it this one, right? Because x is from top to bottom. Okay. So what is the value of s at the top? H, right? So s is the displacement from the ground. Okay. So at h, what is potential energy? What is potential energy at A? H is A, right? mgh, right? And it is the maximum value, right? So let us denote the value of total energy is mgh over here. So this is our first point. What am I trying to do? Trying to plot a potential energy graph. Next point is B. Let us take this is at the height h by 2. X is equal to h by 2. Right? So what is potential energy at B? H minus h by 2 mgh by 2, right? So when height is half, what is the value of potential energy?
mgh.
Yes. So it is mgh upon 2. Let's say this is mgh upon 2. Okay. So where will it appear? Somewhere here. So we are right now only plotting potential energy curve, right? Is everybody with me? Okay. What about C? What is H? 0. So what is potential energy at C?
0.
0. So what is the potential energy graph? So for the given situation, this is the potential energy. Is everybody with me? So I will write this as EE graph or curve. Okay, this is potential energy curve straight away. Now let's plot the kinetic energy, right? So at height h or position A, what is the kinetic energy? 0. So let's use a different curve. So kinetic energy is at h equal at height h, kinetic energy was 0. What about h by 2? So x is h by 2, right? At B we have taken x values h by 2. That is mgh by 2. Same. So kinetic energy is same here, right? Common. Same as potential energy. At zero, at ground, what is it? mgh. So this is the point. So the kinetic energy curve is this. Okay, so this is kinetic energy. What about total energy? What is total energy at H? mgh. So this is total energy. What is total energy at h by 2? ED, mgh. This also mgh. Right? mgh is this. This is the point. What is total energy at C? mgh. This is the total energy. Yeah. So it's 3 in 1 graph. Okay. What is the dotted line indicating? E is equal to mgh. This line is potential energy. This line is kinetic. Okay. We draw it. It is this side. In terms of positions, this is position A, this is position B, and this is position C. The H is changing from 0 to h by 2, H is 0 to h by 2 to h. See, this graph is, you don't have to do anything actually. You have to just make cross. This is how you have to draw it. Doesn't take like first you draw this and then fill it up. Now that you understood, okay. Only the meaning should be understood. So these questions are asked, right? So explain the energy conservation during a free fall of a body, right? So all these things you have to do. Sometimes it will say that also plot the graph between graph of total energy versus displacement during the free fall of the body, and you have to draw this. Okay? Explain that and draw this. Should be easy now. Can I start with the next topic? Okay. So everybody knows a simple pendulum. What is it?
Pendulum which has a time period of 2 seconds.
No, that is seconds pendulum. I'm saying simple pendulum. Any mass like a metal, okay, which is hanged with the massless and inextensible string. Okay, that makes pendulum, and it is hanging through a ceiling. Okay, it is hanging from the ceiling or the roof. Okay, then we call that as simple pendulum. Now what I am doing is I am holding it and taking it to one side. Okay, let us say I am taking it to left, right? So look here, everybody, right now. So what did I do? I am trying to set up oscillations in this pendulum. So for that, what will I do? I will take it to one side. Okay. So let us say it has reached a height h. So what was its initial position? So all the positions we are taking from the center of the bob. What is it called? Bob. Okay. So why are you laughing? Huh? What's the joke? Does it sound like the name of Bollywood villain? There used to be one, Bob Christo. Anybody remembers this place? I think you've learned all this in 9th standard. That this is a Bob and it is not a villain. Okay. Was that looking like a joke or? So how will be the path during the oscillation? It will be like a curvature, circle. It's like a circular path, right? Because this is inextensible, so it will act like a radius. Then its path would be like a circular arc, right? यार हाँ ना बोलो नहीं तो मेरे को समझ में आएगा कि मैं खुद से बात कर रहा हूँ. Respond, okay? So what did I say? When I have taken this pendulum to one side, and when I leave, it will start oscillating. This is called oscillation. What is one oscillation?
To and from motion of the bob.
To and from motion. So what is one oscillation? Let's say I am calling this as position A, this as position B, and this as position C. So what is one oscillation?
A to C and C to B.
Good. So this, if you are taking 2, and this will be pro. We just call it. This is 2, and this is pro. 1, 2, and pro is called one oscillation. Okay. Now what we are imagining is, now pay attention everyone. At B, right? What is the mean position? So at mean position, we are taking the height as 0, right? And at extreme positions, both the sides, it is attaining height h with respect to its initial height. Okay? So what is the gain in potential energy at C?
H.
Gain in potential energy. Let's say mass of the bob is m.
H.
Okay, what will be the increase in potential energy? Let's say at B I'm saying potential energy is 0 because H is 0, right? So P at B is 0, U at B.
For energy.
So at B, what is the potential energy? 0. Because our H is 0. What is the potential energy at C? MgH. What is the potential energy at A?
Energy.
MgH. Understood. What is the kinetic energy at C? 0. Because this bomb when it यहाँ से जब आ रहा है एकदम fast जाके यहाँ से it is reversing. So just before reversing, its velocity is 0. Okay. So at C, its kinetic energy is 0. What about kinetic energy at A? 0. Because same thing. At A, what is the velocity? 0. What about B? Will kinetic energy be 0? हाँ? फिर हंस रही है। तुम्हें बता ही दे क्यों हंस रही है? या मुझे लग रहा है कि तू हंसता हुआ लग रहा है हर बार। ऐसा क्यों? What is the joke? Are you finding this discussion very hilarious or what? Okay. What is the kinetic energy over here? Tell me. What should be rather the kinetic energy?
Half MD square.
ठीक है, but what it should be? So whatever is the velocity at B, that should be its kinetic energy, right? This should be equal to what? Look at the diagram carefully. We are saying energy cannot be destroyed. It changes form from one to other.
2gh. So d square will be 2.
What is Kb here? See, here it was mgh and kinetic energy was 0. Here the potential energy has become 0. So kinetic energy should become mgh. Isn't it? Right? Because energy conversion is taking place, no? So if at B the potential energy is 0, so kinetic energy क्या होना चाहिए? Should be mgh. So what is the velocity at B?
2gh.
Yes. Therefore, velocity at B, its square is 2gh, and therefore Vb is equal to root 2g. Okay. So only this qualitative discussion or quantitative discussion is there, right? So you have to only show that the energy is changing because here velocity is 0, so kinetic energy has to be 0, right? So maximum velocity is at the center and minimum or no velocity at the extreme position. So that's it. So therefore at center there is no potential energy because H is 0. So the total energy over here is only because of kinetic energy, right? So right now, what is the total energy? Therefore Vc is equal to UC plus AC is equal to mgh. हर जगह पे क्या है? Here also. EB is equal to UB plus AB is equal to 0 plus mgh is equal to mgh. Everywhere. Yeah, VK is equal to UA plus AK. So it is same. Okay, so with this we have completed discussion of energy conservation and our chapter is complete. let's get solving questions. So we have some 15 minutes, 17 minutes. So how will you say that the energy is conserved here? What is the meaning of conserve? Don't be shy if you are saying anything wrong, okay? I'm okay with it. It's a learning process. Same, yes, exactly. Conserve का मतलब ये होता है same, it will not change. A, B, C तीनों जगह पे energy कितनी है? Same है. और वो कितनी है? Yes. ये एक statement लिखते हैं, right? Since EA and EB and EC is equal to mgh, therefore energy conservation is verified during oscillation of simple pendulum. Is that okay? Should I write or will you be able to write? Okay, yes statement here. Since EA is equal to EB is equal to EC. Since the total energies, total mechanical energy at position A, B, and C is same, that is mgh. Therefore, energy conservation is verified during oscillations of simple pendulum. Okay? So it's as simple as that. And its velocity is maximum at the mean position. When it crosses the mean position, and its value is √2gh. Okay? This is how sometimes the question is asked. All right. So work, power, energy demands. Question. Okay. So we'll start with this. Shall we start with the previous year board questions? So come to page 23, duty volume. Question 1. You keep on writing in your workbook. Okay. Everybody has got their volumes? Okay. So turn to page 23. So everybody will take turn in reading the question and answer, okay? So we'll start with the girls. So how it goes is first bench, second bench, third bench, then with you it will come back. So volume is either se share karo. Everybody has volume, if not share with each other. Then I'll read the question, you read the question and answer. Start.
Give an example of each when chemical energy changes into electrical energy.
So when chemical energy changes into electrical energy?
1000.
Only the one who is reading will answer. Cell. You when Cell is in use. What will you say? In use. That means when the current is drawn. So that's answer for one. Write down. Everybody write the answer. Answer for first question is cell or battery in use is an example of change of chemical energy to electrical energy. Now what are you doing? Why you don't have a volume? अच्छा, you're opening that conversion chart. ठीक है, वो diagram बोल दो.
Electrical energy changes into sound energy. Speaker.
Loud speaker. Very good. So this is how the questions are asked. Okay. Second is answer is loudspeaker. So when the loudspeaker is at work, electrical energy is converted into sound energy. Next, please.
Define a kilowatt hour. How it is related to.
So what is a kilowatt hour? What is a kilowatt hour? देखा, पता है लेकिन बोले कैसे? सुना है ना किलोवाट आवर? Try even if it is wrong. चलो. किलोवाट किसका यूनिट है? What is unit of? What is unit of what? Power. And hour is unit of?
Time.
Power into time is? Work. Okay, this is work. So work is same as energy. So kilowatt hour is a electrical energy unit. Write down. What is kilowatt hour? It is unit of electrical energy. Write down. So this is the definition for kilowatt hour. It is electrical energy unit. Okay. Right. So how is it related to joule? That's the next part of the question. So 1 kilo. So this is how it is related. 1 kilowatt hour is 1 kilo is 1000 watt into 3600 second. Hour is 1 hour. How many second?
1 hour.
Has 60 into 60, right? 3600. Everybody got it? Why have I written hour as 3600? Because it has 3600 seconds. So what is it now? So this is 36 followed by 5 zeros. Watt second. Now watt second is joule. Okay? Because watt and second, these are both SI units. So we can write therefore, I can write this as 3.6 into 10 raised to 6 joule. This is how it is. So once you have everything in SI unit, then it has got a special name, joule. Watt second is joule. Okay. So this is the relation. Okay. You.
A satellite revolves around a planet in a circular orbit. What is the work done by the satellite at any instant? Give a reason.
Yes. बोलो क्या होना चाहिए? So question 3. Satellite कैसे घूम रहा है? This is Earth and this is your satellite. So satellite is revolving around Earth in a circular orbit. What is the work done? Anybody want to try? Raise your hands. 0. Who said that? Why? He also said 0, right? But you are not sure. Are you sure? No.
0.
So why? 0 is correct. Now would you like to explain why it is 0? See? So where is the displacement? It is in this direction. Any body in the circular motion is attracted towards center. The force acting on the satellite is towards the center, centripetal force. What is the displacement? Along this. So what is the angle? So what is the work done? So F(s) into 0. This is 0. Cos 90 is 0, right? So what is the angle between displacement? Displacement is along the tangent at this point. So tangent is always perpendicular to radius. पता है ना? So the angle between displacement and force at any instant, कहीं पे भी, it will always be 90. So the work done on the satellite is 0, or by the satellite is 0. Okay. Has everyone understood? Say yes, sir. I will feel confident and motivated. Sometimes even when you don't understand, say yes, sir, with a big nod. Yes, sir. Teachers are very happy. Okay. No, you don't have to say that. Okay. If you don't understand, you say, sir, बताओ क्या है? So, is question 3 understood by everybody why the work is 0?
Yes.
Next, question 4. Whose turn? Go ahead. 200 gram बोलो ना. हाँ.
It is displaced from the mean position A to the extreme position B. The potential energy at position A is 0.
Okay.
At the position B, the pendulum bob is raised by
Bob is what is causing. Now I got the reason. Is raised by 5, but don't miss the point. हंसने के चक्कर में, ठीक है? At the position B, the pendulum bob is raised by 5 meters. So the question क्या है? 3 questions you have to answer based on this diagram. ठीक है? What is the potential energy of the pendulum at position B? Yes, very good. So let her answer. I want everybody who is reading should try. Okay? So everybody should be able to have a go at the question. So what is the potential energy? mgh. Okay. What is mass? 200 gram. You have to convert that in kg. How much it will be? What's her name? Your name? Huh? Nihali. Nihali, what is the mass in kg? 200 grams is 2 kg. 1000 grams is 1 kg. So 200 grams is 0. Divided by 1000. Okay. See, sometimes you make silly mistakes like this. ठीक है? तो इसलिए practice करना है. M is 0.2 kg. Now what is G? You can take G as 10. It's given in the question. Okay. So into 10. What is the height? 5. Okay. So 0.2 into 10 is 2, 5. So it is 10 joules. That's the energy. So what is the potential energy at B? 10 joules. Now, so this is the first part of the question. Second part of the question, Nihali. Yes. So what is the total mechanical energy at point C? C is somewhere in between. चलो देखते हैं कौन बताता है. हैंग कर दूंगा ऊपर. अभी हम पढ़ रहे हैं क्या? कंजर्वेशन ऑफ एनर्जी. क्या मतलब होता है? MGH. It is same throughout. Throughout, we discussed A, B, C point. Any point throughout the journey, the total energy will be MGH. क्योंकि टॉप पे पोटेंशियल एनर्जी था, काइनेटिक था ही नहीं. बट बीच में क्या होगा? सम पार्ट विल बी पोटेंशियल, सम पार्ट विल बी काइनेटिक. लेकिन वो काइनेटिक बना कैसे? MGH में से ही लिया. ठीक है? यही मीनिंग होता है. So now that you know the total energy was 10 joule, तो ये भी 10 joule ही होगा हर जगह. Got it? Simple. Okay. What is the speed of the bob at the position A when released from B? बताओ निहाली. अरे अभी तो बता है. See the diagram pendulum का. What is V at B? What is VB? Root 2 GH. अभी बताया ना. बॉटम में स्पीड क्या है पेंडुलम का अभी तो बताया था माय डियर. जस्ट सी द थियरी. अभी नोटबुक देखो अपना. पेंडुलम का जो केस बताया था. व्हाट इज द वेलोसिटी एट v? डिड आई टेल रूट 2 gh? दैट्स व्हाट इट इज.
And the speed can't vary.
हां,
Can the speed not vary in different pendulums?
हां, इट विल बी mgh ओनली ना. mgh से ही तो आया. एंड दैट यू हैव टू इक्वेट टू हाफ mv स्क्वायर. So you get the same thing. Right? So what is varying is h. This h. So here it is 5. So you have to substitute your. So 2 g is acceleration due to gravity given 10. H is 5. So this is root. So this is 5 into 2. 10 into 10. So this is 10 meter per second. Okay? ठीक है ना? So in these conservation energy problems, we have to assume that there is no loss of energy. ठीक है? In friction. So everything of potential is getting converted into kinetic, and then kinetic is getting converted into potential. At the mean position, it is all kinetic, and as the height increases, the potential energy increases. At the extreme position, it is all potential. यही समझना है. ठीक है? तो अभी मजा आएगा. सो नेक्स्ट क्लास में पूरा न्यूमेरिकल करेंगे तो तुमको एक्सपर्ट बनाएंगे. ठीक है? सो दिस इज वेरी इंपॉर्टेंट चैप्टर. अगर ये तुमने ठीक से समझ लिया तो तुम्हारा फिजिक्स विल बी गुड इन फर्दर क्लासेस एज वेल. ओके, ऑलराइट, सी यू इन द नेक्स्ट क्लास. इज इट टाइम?
Yes, sir.
ओके, सी यू इन द नेक्स्ट. थैंक यू.
तुमने कैसे बनाया? मैंने बहुत गंदा बनाया. वापस करा. 2 बार कैंसिल किया. नाम चिल्लाई नहीं. राउंडर नहीं. ठीक है ना? हम डांटने वाले सर के लिए. तो प्लीज चेंज करने की गलती नहीं करें. इसमें ये तक को भी सुनना नहीं था. देखो आदत नहीं है भी सुनने की. मतलब डांट सुनना ही नहीं है. लाइफ में मुझे प्रॉब्लम है. हमने सुना दिया और इतने से नहीं सुना.